All right, let's get started. I'll wait till there's a couple more people in, and then we'll get started. I won't wait for too long for those of you that are waiting. By the way, if you check the video description, there's a link for the test that I'm going over, the SAC. Yeah, so if you go to the video description, you should be able to see this test right here. To be honest, guys, I haven't looked at this test in a while, and so if I do a problem in a way that you're like, wait, you could definitely do it faster this way, then just let me know. There's a good chance that you're right. Um, okay. If you guys have questions as I'm going, feel free to stop me, like comment and be like, "Oh, I want to go over this problem." And if no one says anything, then I'm kind of just gonna um, work continuously. I'm just gonna go through the test. Like I'll do number one, number two, number three. If you have questions, or if someone wants me to like skip to the calculus or skip to the statistics or um, something like that, then just leave a comment and yeah, leave a comment and I'll do that. But if no one says anything, I'm just gonna start at the beginning. All right, we have a couple of people. Ooh, I've made a mistake. Here we go. I've got the pad ready, and we can get started. Okay, let's see. Number one, at this restaurant, they ordered 4 smoked chicken dinners for $17.95, 4 iced teas for $2.29, 2 slices of apple pie for $4.25. That's the tax rate, and you paid with a $100 bill and one $20 bill. Okay, so this is just your basic consumer problem. We don't really have to go through this one. To get the price after tax, you multiply by 1.08125. That's really all there is. Um, let's see. The second one, consider the line with points -3, -5, and 5,7. And it says the line contains the point 0b. Okay. So there's two ways that come to mind on how to do this. One's probably faster than the other. One way you could do this is you could actually find the equation of this line, which to do that you would use point slope. So you would find the slope, which would be 7 minus -5 over 5 minus -3, which would be 12 over 8, which is 1.5. Yes. And then use one of these points. It doesn't really matter which one. I'll use this one. So you get y plus 5 equals 1.5 times x plus 3. And then if it's at 0b, then you just plug in 0 for x. So y plus 5 equals 1.5 times 3. And so y equals -0.5. The other way you could do this that I kind of like is you can take advantage of the fact that this is linear. And I know we kind of did that, but this is what I mean. So going from -3 to 5, that's x. Your x is increasing by 8. And between those 2 points, your y's are increasing by 12. Well, if an increase of 8 results in an increase of 12 in the y, then going from -3 to 0, which is an increase of 3, the y should increase proportionally. So instead of going from an increase of 8 being an increase of 12 in the y, an increase of 3 would be 3/8 of 12, which is 4.5, and then negative 5 plus 4.5 gives you the same answer of negative 0.5. Okay, if there's anyone new, this test is in the description, so you can go through that if you have questions. If you want me to skip to something, just let me know. Otherwise, I'm just gonna keep going. We're gonna go until 4:30, by the way. We're just gonna see how much we can get done by 4:30. If it's 4:30 and there's still stuff that you guys want, then I can just do another one. I'm gonna try to do these a little more regularly than normal, just because it's summer now and I don't have to worry about like senior stuff. You know. All right, and I'm gonna go ahead and every single time I do a problem, instead of erasing, I'm just gonna scroll down, and that way, if someone has a question in the future that I've already gone over, okay, let's see this next one. So, Joe sets the motor of a small boat to travel. Ooh, hang on. To travel at its maximum speed. At the setting, he travels 36 miles upstream against the current in 9 hours, and then turns around and travels 36 miles downstream with the current in 6 hours. What is the maximum speed of Joe's boat in still water? Alright, so this is saying when he's traveling upstream, you go 36 miles in 9 hours, or which is the same thing as 4 miles per hour. When you go downstream, now I've got the current working with you, so now I can go 36 miles in 6 hours, which is the same thing as 6 miles an hour. So the way you can solve this is with a system of equations. So there's two speeds working on the boat. You have the speed that the boat can go by itself, and then you have like the current working for or against it. So when it's working upstream, you have the speed of the boat, that it would be like if it was staying still, and then minus the speed of the current, because the current is working against it. And that equals 4, right? 36 miles in 9 hours, 4 miles an hour. Now, if you're going downstream, the current is working for you. So it's the speed of the boat in still water plus the speed of the current, right? Because we're going downstream, and that equals 6 miles an hour. And this is a pretty basic system of equations. You can add the two equations, right, to make the c's cancel out, right? And so 2b equals 10, so b equals 5, and so that's our answer. Yes, all right. I see that we have a couple more people. If you check the description, there's the test that I'm going over. This is the 2022-2023 Student Activities Conference mathematics test. So you can check the description and go there. If you want me to skip to something, just leave a comment. But if no one leaves a comment, I'm just kind of gonna keep going through. All right, moving on to number 4. Kind of speed running these. If you guys want me to stop, just say so. All right, last summer we drove from Lubbock, Texas to McMinnville, Oregon to see relatives. On day 1, we drove 600 miles at 62 miles per hour. On day 2, we drove 620 miles at 68 miles per hour. And on day 3, oh, and on day 3, we drove 534 miles at 60 miles per hour. What was our overall average speed for the trip? Okay, so the way you do these, overall average speed, so average speed is just total distance divided by total time. Well, our total distance is pretty easy to find out, right? We just have 3 legs, and so we just add 3 of those together. And keep in mind, these are in miles and hours, right? Because that's what our answer choices are going to want. So that's all miles. And then our total time, well, we have to calculate the time for each individual one, right? And so if speed equals distance over time, or you might see it like this, distance equals rate times time, then we can find the time that it took on each of the days. We can rearrange this formula to get time equals distance over rate. So the time it took on day 1 would be 600 over 62. The time it took on day 2 would be 620 over 68. The time it took on day 3 is 534 over 60. Let's see. What happens when we type all this in? Give me a second. It's like you get 63.3 miles an hour. Sweet. Okay, moving on. Where is it? Here we go. Oh, I keep going to the wrong thing. Here we go. Okay, let's see. Jim can clean my pool in 75 minutes, Tom can clean my pool in 90 minutes, and Julie can clean my pool in 60 minutes. If all 3 of them work together, how long would it take them to clean my pool? Okay, it's kind of a distance rate time problem in disguise, but I'll show you what I mean by that. So I like to set up these tables. I think they're really helpful. So this is rate time. Here's Jim, here's Tom, and here's Julie. So, and I say distance rate time, it's really just like a rate problem. Um, your distance is a little bit weird, but you'll see, you'll see. So instead of distance, I'm going to think of this as number of jobs. And then rate would be, well, everything's in minutes, so I'm going to call it jobs per minute. And my time will just be in minutes. Well, let's look at Jim's. How many jobs would Jim do if they all work together? Well, it looks like we're going to have to solve for that. But we do know his rate in jobs per minute. If it takes him 75 minutes to do one job, then we know his rate is 1/75th jobs per minute. And same logic for Tom and Julie, right? So Tom will be 1 over 90, and Julie will be 1 over 60. Let's see. We don't know how long they work, but we do know that they all work for the same amount of time. So I'm going to call each of these just T. So look what we can do here. We don't know what the individual numbers of jobs that Jim, Tom, and Julie do, but we do know how long it takes them all together, right? So, um, so we know the number of jobs they do altogether is 1, right? Because it says how long will it take them to clean my pool. That's 1 job. And that'll be the amount that Jim does plus the amount that Tom does plus the amount that Julie does. So the amount that Jim does is 1 over 75 times T. The amount that Tom does is 1 over 90 times T. And the amount that Julie does is 1 over 60 times T. So if we factor out a T, you get T times 1 over 75 plus 1 over 90 plus 1 over 60. And so the time it takes them is 1 over 1/75th plus 1 over 90 plus 1 over 60. And what does this give you? 24.3 minutes. There you go. Answer choice A. Moving on. Keep zooming in too far. All right, moving on to number 6. Um, If anyone else is here right now, that wasn't before, if you guys have questions, from this test that you want me to skip to, just let me know. Other than that, I'm kind of just gonna keep moving. I'm just gonna keep working through the test. Okay, let's see, number 6. Here we go. Okay. Alright, consider the line y equals f of x, which contains point P and is parallel to the line shown on the right. Find the value of f of 9. Okay, so looking at this graph, we can tell that the point what am I trying to say? Wait. Yes, okay, so f of x contains point P and is parallel to this line. So it's going to look something like this. I'm not very good at drawing on this computer, but you get the idea. It's going to look something like this. Anyway, what we're just trying to find f of 9. So what's the value of this at x equals 9? Well, what we can do is see, well, if it's parallel, then that means that they have the same slope, but one of them is just shifted down. And we can see from right here, if you look at point P, it's shifted down from 6 to -2. So pretty much everything on this line right here is just shifted down by 8. So we can find what 9 is on this line and just subtract 8. So looks like 9 on here is right there. And we can tell from the slope that that's going to be exactly halfway between. So that's at -7. So -7 minus 8 gives us -15. Sweet. Let's keep moving. If you guys want me to skip to the calculus, just say so. I don't want to bore you guys, but I also don't know what people need to see if you guys don't comment. All right, we've got another system of equations problem, it looks like. All right, the UAL students at Latexo High School sold 246 tickets to the end of the year banquet. If adult tickets cost $18, student tickets cost $12, and $3,816 was raised, how many student tickets were sold? So we can set this up as a system of equations where you have two variables and they're the number of tickets sold. So I'm going to call the number of adult tickets A and the number of student tickets S. So we know that altogether there's 246 tickets sold. So A plus S equals 246. And we also know that the total amount of money raised was 3,816. So if an adult ticket is 18, student ticket is 12, then 18 times the number of adult tickets sold plus 12 times the number of student tickets that were sold gives you $3,816. So just solve the system of equations, which I am doing right now. 18a plus 12s equals 16. How many student tickets were sold? Yep, you get 102 student tickets. Nice, moving on. Well, they really like their system of equations on this test, I guess. Question 8, we're going to have 3 of them. Alright, so Mary has 57 coins that are either nickels, dimes, or quarters. The value of the coins is $8.60. She has 10 more quarters than nickels. How many dimes does she have? So yeah, this is literally just another system of equations. So our total number of coins is 57. So N plus D plus Q is 57. The value of the coins is $8.60, which I'm going to make 860 cents just to make it a little nicer. So 5N plus 10D plus 25Q equals 860. And then she has 10 more quarters than nickels. So what does that give us? So if you add 10 to the number of nickels, then you will get the number of quarters because you have more quarters than nickels. Alright, so if I solve this system, give me a second. N plus D plus Q equals 57. 5M plus 10D plus 25Q equals 860. And 10 plus N equals Q. How many dimes does she have? Well, that's going to be 19. There we go. Alright, moving on. You can check out this test if you go into the description. I'm pretty sure I posted it there. Yep, it's the first link in the description, or the only link in the description. So you can go there, see if there's questions you want me to skip to. But yeah, we're gonna keep rolling. All right, let's go. Oh, wrong thing. Okay, number 9. Find the number that is 3/4 of the way from -1/2 to 6 5/8. So first thing you have to do is find the total distance between these two things. Right, so the total distance between -1/2 to 6 5/8. So that's just going to be the difference between those two, which is, if you just subtract those, that gives you 65/8. So that's the total distance. And then you want the number that is 3/4 in between. So to find the number that's 3/4 in between, you begin at your starting point, which is -1/2. And then if this is your ending point at 6 5/8, you want 3/4 of that. So you find 3/4 of the total distance and then add it to your starting point. So 65/8 times 3/4, and then plus -1/2. You end up with 147/32. Oh, okay, but all these are in mixed numbers, so that's not super helpful. But I do see that all of these whole number parts are 4. So if I just subtract 4 from this, I get 19/32. So I can tell you that it's answer choice A. All right, moving on to number 10. I might have said this before, but if I don't get through all the ones that I want to, then I can just do another live stream that's just like the rest of this test. That could be pretty useful, I think. Okay, number 10. Okay, if f of x equals 2x plus 5 over 3 minus 7x, then the inverse of f at 2, the f negative 1 of 2 equals what? So basically, when you're taking the inverse function, you're basically just switching your x and your y's, right? Like if I was trying to find the inverse function of y equals x squared, what I would do is I would just flip them. I would say, well, now I have x equals y squared, and then I would solve for y. And so the inverse of this equation of y equals x squared would be y equals square root of x. Well, the good thing is that this is pretty general, and this is only one case. This is only at x equals 2. And so instead of flipping all your x's and your y's, where you would normally plug in 2 for x with this function notation, now you can plug it in for y. So basically what you're doing is just solving this equation. Okay, and what does this give you? So it's 2 equals, and I've already forgotten what it is, 2x plus 5 over 3 minus 7x, 1/16. There you go. You got answer choice A. Alright, still going. Still going. Alright, we gotta find the perimeter of this right here. We gotta find the perimeter of this region. Alright, well, this is a little bit annoying, but at the end of the day, it's really just a shoelace theorem. not a shoelace theorem. Distance formula. I'm skipping ahead. So let's see. If I label these A, B, C, and D, just so it's easier to talk about them. If I've said AB, right, the distance between 2 points, it's very similar to the Pythagorean theorem, but it's just the square root of the change in x squared plus the change in y squared, right? And you can see that because you imagine we make a right triangle between these two, right? The distance is the hypotenuse. The change in x is one of your legs, and the change in y is one of your legs. So then you just do that for all of these, and you end up with all your distances, right? So tangent x squared for between a and b is from -6 to 2. So that's 8 squared is 64. And then your change in y is from 4 to 8, which is 4 squared is 16. And let's see, from b to c, our change in x is from 2 to 8, which is 6 squared is 36. Our change in y is from 8 to -4, which is 12 squared is 144. Then from c to d, our change in x is from -4 to 8, which is 12 squared is 144. Our change in y is -4 to -8, which is 4 squared is 16. And then finally, from d to a, our change in x is from -4 to -6, which is 2 squared is 4. And then our change in y is from -8 to 4, which is 12 squared is 144. So then if I add all these together, I get 47.2. Hopefully I did that correctly. Yep. There you go. That's answer choice E. Alright, now we have to find the area of this, which is actually a little bit easier if you know the quick way of doing it. So there's this formula for finding the area of something on a grid, and it's called Pick's theorem. I think it's a little bit easier than shoelace theorem, but you have to use shoelace theorem if you're just given the points. But in this one, we're given the graph, you can use Pick's theorem. So it's basically for finding an area of something on a lattice, and it gives the answer in square units. So be careful, at the end we're going to have to multiply by 4 because each unit is a 2 by 2 box. But anyway, it's the number of lattice points on the boundary divided by 2 plus the number of interior points and then minus 1. So if we count this, how many boundary points are on our shape? We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so our b is equal to 8. So 8 over 2 gives us 4. And then what about interior points? You got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Hopefully I didn't miss any. So our interior is 31, and then you just always subtract 1. Right? And this gives you 34. But remember, this is in square units. And each of our boxes here, you can see our x's and y's are both counting by 2. Our x's and y's are both counting by 2, and so each square unit is actually going to be 4, because it's a 2 by 2 box. So 34 times 4 gives you 136 square units. Yep, that's an answer choice, B. Alright, moving on to number 13. I think how I might divide this stream up, you guys like this idea, is I might just go and do everything up until the calculus and statistics, and then have another stream that's just the calculus and statistics. Tell me if you guys like that idea. Okay, let's see. Consider triangle ABC with AB equals 18, BC equals 14. Point D lies on AC such that BD bisects ABC. If AD equals 10, then DC equals what? Okay, so always draw a picture. You get a triangle, don't even read the rest of the question. Just draw a triangle and then read the rest of the question. All right, so we got ABC. With AB equals 18 and BC equals 14, point D lies on AC such that it bisects this angle. Okay, so it bisects this angle. So that and that are going to be equivalent. It tells us that AD equals 10, and so we need to find DC. So you see this BD bisects ABC? Well, it's kind of fun. There's actually a theorem called the angle bisector theorem, which, is pretty useful for this question. And it basically says that the side adjacent the bisected angle, or the side adjacent the angle that's bisected, divided by the opposite is going to be equal to the adjacent divided by the opposite. So in this case, for this triangle, the adjacent to this angle is 18, and opposite that angle is 10. And then for this angle right here, adjacent to that is 14, and the opposite is DC. That's what we're solving for. And so DC is going to be 10 times 14 divided by 18, which gives you 7.78. Nearest tenth, okay, so 7.8. Yes, that's an option. Good. Okay, we got to use this graph for the next two problems. Oh, keep doing that. Use this graph for the next two problems. All right. So we have CAD equals 19 degrees. Always draw these as you go. So angle CAD equals 19 degrees. CD equals 120 degrees. Okay, so this arc right here. I see what they mean. This arc right here is 120 degrees. And DE, this arc right here, is 102 degrees. We're trying to find BC. Okay, so we don't really have a lot of ways of finding BC directly, but we do have a way of finding BE. So if you have secants like this going through a circle, so you can see these two lines go through the circle. They form an angle over here, and then you see they create two arcs with the circle. So they create CD and they create BE. So this is the formula you can use. The outer arc minus the inner arc divided by 2 gives you the angle between lines. So for this problem, right, our outer arc is CD, which is 120. Our inner arc is BE, we don't know what that is yet. Divided by 2 gives you the angle between the lines, which it tells you is 19. So if we just solve this really quick, you get X, or BE, is 82 degrees. Okay, so now what can we do with this? Well, we know the arc all the way around a circle is 360 degrees, right? And we have everything around the circle except for BC. So BC equals 360 minus 82 minus 102 minus 120. Which gives you 56 degrees. There you go. All right, now we have 15. Okay, so this looks like it's going to be a power of a point, just glancing at it. But I'll still read it. All right, so if BD intersects CE at point P, okay, so we're drawing these at point P, with BP equals x plus 1, CP equals 2x, DP equals 2x plus 2, and EP equals x plus 4, then CE equals what? Okay, so we can solve for x here using power of a point formula, which basically says if you have two chords in a circle that intersect, the product of like the opposite segments of each other will end up being equal. So this is an example with like numbers to make it a little bit nicer. So let's say okay, this isn't to scale. Okay, take this. Right? Let's say this side, this segment is 3, this part is 2, this one is 1, and this one is 6. And we know this is true because the ones opposite each other, they multiply to be the same thing. So 2 times 3 is 6, and 1 times 6 is 6. And so this checks out with power of a point theorem. So we can apply this here. We have everything in terms of x, so we can use it to solve. So let's take this one first. You get x plus 1 times 2x plus 2, right? Those are opposite each other. And then that equals 2x times x plus 4. So if I solve this for x really quick, I get x equals 1/2. Or, yeah, I get x equals 1/2. And I'm trying to find what CE equals. Well, CE is this whole thing along here. So it's x plus 4 plus 2x, so 3x plus 4. And so if I plug 1/2 into that, it would be 3/2, which is 1.5, plus 4 gives you 5.5. Right? All right, let's keep going. Any new people that have joined? I can't see without like exiting out of the screen who all has joined, or how many new people we have. But any new people that have joined, the link to the test is in the description of the video. So what you can do is you can look at the test, see if there's anything you want me to skip to. If you just want me to skip to the calculus, maybe you're a junior or senior that's just hasn't gotten to that yet, or maybe I don't know, maybe you're just a 7th grader that's tuning in because I don't know, because you just like math. That's pretty cool. Anyway, if you want me to skip to something, leave a comment and I'll skip to it. Otherwise, I'm just going to keep rolling. Okay. All right. Consider a right circular cone with a base perimeter of 75 centimeters and a lateral area of 490 centimeters. Find the volume of the cone. All right. So what do we have? Well, to find the volume of the cone, you need a couple things, right? Because volume of the cone is 1/3 pi r squared h, right? So we know, so it has a base perimeter of 75, so we can use that to find r, right? If the base perimeter is 75, then 75 would be the circumference, which is just 2 pi r. So our radius would be 75 divided by 2 pi, which is like 11.94 centimeters. And it also tells us we have a lateral area of 490 centimeters. So I wonder, can we use that to solve for the height? Well, yes, you can actually. The formula for the lateral area of a cone, the lateral surface area of a cone, equals pi times the radius times your lateral height, which is like your slant height. So you can solve for your lateral height by doing 490 divided by pi and then divided by r, which we just found. So you get your lateral height as 13.07. Well, how does that help you? Well, I'm going to draw a cone. Maybe this will make it a little bit more, make more sense. There you go. Okay, so here's your radius. Here is your slant height. This is what we just solved for, this L. And we're trying to find the height, because if we do that, then we'll have r and h, and we can solve for the volume. Well, if I drop this perpendicular right here, this r is 11.94. Our L is 13.07, and I realize I've drawn this not even close to scale. You can see we can just use Pythagorean theorem to solve for the height, right? That's L squared minus R squared should give us the height. So we get a height of 5.32. Now we have everything we need. So just plug this into the volume formula. So 1/3 pi times 11 point. Times 11.94 squared times our height, which is 5.32. That gives you a volume of, oh man, I did something wrong. Oh, I forgot to multiply by pi on my calculator. 793. Nice. All right. We're going to keep rolling. All right. Consider a circle inscribed in a square. Okay. Fair enough. Here's our square. That is an attempt at a circle. With side lengths of 44.6. And we don't have to worry about the units because, look, our units down here are also the same units. So side length of 44.6. Find the area inside the square but outside of the circle. So this is pretty straightforward, right? You just find the area of the square, subtract the area of the circle. Area of the square is just 44.6 squared. And the area of a circle is pi r squared. Well, and you can find the radius by saying, well, look, the radius is going to be half the side length. So 44.6 over 2 squared. What does that give you? Gives you 427. There you go. Pretty straightforward. Okay. Ooh, we got some little direct and inverse variation here. All right, man, keep doing that. Okay, 60 workers can do 9 jobs in 6 days. How many days would it take 10 workers to do 12 jobs? Okay, so to start with the number of days originally. So we have 6 days. And just take it term by term. So if we have 60 workers and you go to 10 workers, well, now we have a sixth as many workers. So it's going to take 6 times as long, right? So multiply by 6, because now we have a sixth of the people working on it. Well, now we're going from 9 jobs to 12 jobs. So that's a factor of 12 ninths, right? And is that going to make it take more time or less time? Well, if you're doing more jobs, it's going to take more time, right? So just multiply this by 12 ninths, which I guess is 4/3. You get 48 days. Pretty easy stuff, but still worth going over. All right, this is one that you don't see a whole lot, actually. All right, consider the line y equals f of x such that all points in the line are equidistant from the points -6, 8 and 4, -6. The y-intercept of the line y equals f of x is 0, b. Find b. Okay, so if the line is equally distant from these 2 points, another way of saying that is it's going to be the perpendicular bisector. And you can this is how you can show it. You can kind of prove it to yourself a little bit. This isn't going to be like a formal proof, but say that's point A and that's point B, and this is the perpendicular bisector, right? So any point on here, right, if I draw these lines, which would be the distances, right? If this is the midpoint, then we know these two are the same, and we know that they share this leg in common. So by the Pythagorean theorem, right, we know that these two lengths are going to be the same. So, perpendicular bisector. So, we just have to find the perpendicular bisector of this right here. So, the midpoint between these 2 points, -6 plus 4 is -2, so that's -1. 8 plus -6 is 2, so that's 1. So that's the point that it's gonna go through. And let's see, what's the slope? So the slope between these 2 points, it's like this, right? Negative 6 minus 8 over 4 minus negative 6 is negative 7/5. So to find the perpendicular slope, it's the opposite reciprocal. So this turns to just 5/7, right? So to find the equation of this line, we can just use point slope. That's why I found the slope and found the midpoint. So the equation of this line would be y minus 1 equals 5/7 times x plus 1. And if we're looking for when x is 0, take this out, right? 5/7 times 1 is 5/7 plus 1 gives you 12/7. Pretty easy stuff. Okay. Alright, we're going to find the domain of this function. Square root of 3 plus x over x squared minus 9x plus 20. Okay, let's see what we have to do here. So what things are going to restrict our domain in this case? So we have something in the denominator, and so looking at this right away, we know that this cannot equal 0. If that equals 0, that's a deal breaker, right? Like, nothing doesn't matter what's in the top. It just doesn't work. And then we also have a square root in the numerator, and we know that anything under the square root has to be greater than 0 or greater than or equal to 0, or else you're going to get something imaginary, and then that doesn't work. So let's start with the denominator. So x squared minus 9x plus 20. Well, when is this equal to 0? Looking at this right now, I can actually factor this to x minus 4 and x minus 5. So when does this equal 0? This equals 0 when x equals 4 and when x equals 5. So we can immediately take these out. So little process of elimination, we can take out d, and that's it. They kind of just expect you to know that one. So then for the numerator, we know that 3 plus x has to be greater than or equal to 0, which means that x is going to be greater than or equal to negative 3. So it looks like we're stuck with answer choice C. All right, we're at number 20. Let's keep going. I think I'm just going to go until we hit the calculus and statistics, and then we'll do that in another stream. Okay, actually, I'm not even going to do this one. So number 21 is really just, you're actually just typing this into your system solver. I'm not really sure why this is a question, to be completely honest. Maybe there's a really quick way that I'm not seeing, but yeah, you guys can solve a system of equations. And number 22 is just typing things in. Number 23 is just function notation, right? If you've taken algebra 1, then you can do number 23. Just make sure you're in radians is the only thing I can think of. All right, so we're going to skip to 24 because those few were pretty self-explanatory. You didn't need me to do this. All right, James has 6 calculus books and 8 physics books on his bookshelf at home. How many arrangements are possible if he keeps the calculus books together and the physics books together? Okay, this is how I like to think about these questions. So whenever you're keeping them together, right, I like to think of it as just like one big book, right? So my 6 calculus books are actually just one big book, and my 8 physics books are actually just one big book. So it can either go calculus and then physics, or it can go physics and then calculus. Right? You only have 2 possibilities. But within each of these books, which within each of your big calculus books, your big physics books, you have 6 little calculus books and 8 little physics books. Well, how many ways are there to arrange each of these? Well, to arrange 6 things in a line, that is 6 factorial ways. To arrange 8 things in a line is 8 factorial ways. And then you can either go calculus physics or physics calculus, so then you have to multiply by 2. So if I multiply all these things together, you get 58,060,800. Sweet. Okay, let's keep going. We're making some good progress here. Alright, each of the wheels on Russell's what in the world? Jumbo wheel swamp buggy. There you go. That's interesting. Has a 4-foot diameter. When he's traveling at 42 miles per hour, what is the angular velocity of the wheels in revolutions per minute? Okay, so for this one, it's basically just like a unit conversion problem, is the way I'd like to think about it. Anyone that's done like chemistry, you've done like the fractions where you cancel stuff out, where you cancel the units. Yeah, it's kind of like that. So I'm starting with 42 miles per hour. Okay, and then each of the wheels has a diameter of 4 feet, and so I'm going to get my miles to feet to make this a little simpler, right? And then I'm going to say 1 revolution, right? Because the diameter of my tire is 4 feet, 1 revolution is going to be 4 pi feet, because that's the circumference of the tire. So as of right now, my miles have canceled, my feet have canceled. So right now I'm in revolutions per hour. I just need revolutions per minute, so that's pretty straightforward. 1 hour is 60 minutes. Cancel those out. And so now I have revolutions per minute. And I just need to figure out what this is equal to. 294 revolutions per minute. There you go. Okay, moving on. 26. Vertex of the parabola y equals negative 4x squared plus 6x minus 8 is the point A, comma B. Find A plus B. Okay, so x coordinate of the vertex. Here we go. X coordinate of the vertex is equal to negative B divided by 2A. You could also do this with calculus if you wanted. You could derive this instead of equal to 0 to find the vertex, but I like this a little bit better. So that would be negative B. So my B is 6. So that's negative 6 divided by 2 times A. Well, my A is negative 4. So when I do this, my negative signs will cancel, and then I get 6 over 8, which is 3/4. So my A is equal to 3/4, if you do this based on the problem. And then to find B, all you have to do is plug your x coordinate in to find your y coordinate. So if I do that, I get negative 23/4. And then to find A plus B, just add those two together, and you get negative 5. All right, we got a little pre-cal here. Starting to get a little trickier. And I'm going to stop doing that eventually. I think I've gotten the muscle memory, but it's like the wrong muscle memory. Okay. We have multiplying these two complex numbers. Multiply 6 cis of 60 times negative 4 cis of negative 150. So if you guys are unfamiliar with what this what this notation means, one way that you can express a complex number is by how far away from the origin it is, and also the angle that it makes with the positive x-axis, like that. And if this has a length of r, and that's an angle of theta, they call it r cis of theta. And that's because you can express it like r cosine of theta, or sorry, r times cosine theta plus I sine of theta. So here's your r is right here, and then it's cis because it's cosine I sine, right? CIS, cosine I sine. Right? Because you can imagine if you had this on the complex plane, right? Here's your real axis, here's your imaginary axis. Boom, here's your complex number. And I drop this down. If that has length r, that's angle theta. Then my real part is just the length of this leg down here, which with trigonometry, right, would just be r cosine theta. And then for the imaginary part, same thing, right? Just SOHCAHTOA gives you r times the sine of theta. right? And then I have the I in front of it because it's in the imaginary plane. So there's a rule that you can use whenever multiplying complex numbers in this form. So your magnitudes will multiply together and your angles will add together. So when I'm multiplying these two, 6 times -4 is -24, and then 60 plus -150 is -90. Okay, so this is the same thing as -24 times the cosine of -90 plus I sine of -90. And these are in degrees. I forgot to write that. These are in degrees. All right, so what's the cosine of -90? Well, -90 is just going 90 degrees clockwise instead of counterclockwise. So that's going to be 0. It will be the same thing as cosine of 270. Right? That's 0. And then sine of -90 would be -1 times I would be -I, and then so -24 times -I just gives you 24I. Right? So that's answer choice D. By the way, if you want to look more into this, this is actually called wait, nope, that's the wrong thing. I was thinking of something else. Ignore that. I'm sorry. Okay. Okay, 28. Alright, Sarah released 36 bunnies into the woods near her house. 6 months later, the population had increased to 100 bunnies. Assume the bunny population is increasing exponentially and calculate the expected bunny population 21 months after the original release of 36 bunnies. Okay, so we have a little bit of information here. We know that the population at time equals 0 equals 36. We know the population at 6 months equals 100. Assume the bunny population is increasing exponentially. Okay, so there's so we have these two things. The general form for a so the general form for an exponential is y equals some constant out front times e to the bx. That's just the general form of an exponential. And so this a is like a starting point, and this b is like a measure of how quickly it's growing. And the reason why they give us this thing at 0 is because when you plug 0 into here, into this equation, it doesn't matter what b is, you're still going to get e to the 0th, which is 1. And so if I plug in 0 for x, right, I'm just going to get y, which it tells us is 36, actually, equals a. And so that's part of the, like, now we've already solved for a. So now we only have one constant to solve for. And that's why they give us this one, right? So now we have 100 equals 36 times e to the b times 6. We can use this to solve for b. So divide everything by 36, take the natural log, and then divide it by 6. So you get b equals 0.170. So b equals 0.170. So now we have our complete equation, right? We know our population as a function of time equals 36 times e to the 0.170 times x, or times t, I guess. So it says, assume that bunny population is increasing exponentially and calculate the expected bunny population 21 months after the initial release. So all I have to do here is just plug in 21 in for t and see what this gives us. And you get 1,286. Nice, there you go. There's also a way of doing this. For those of you that have an Inspire, it's a little bit faster. I'll go ahead and show it just because. I mean, if you have this calculator, you might as well try to be fast. I mean, you only have 60 questions. You only have 40 minutes for 60 questions, so you want to save time wherever you can. So you go to your Inspire, you go to Statistics, Stat Calculations, And this is where most people go for linear regression, but most people don't know that you actually have an exponential regression right here. So my two time values were 0 and 6. My two population values were 36 and 100, right? And it says it saves to equation 1. So if I do f1 then of 21, it gives me the same answer of 1,286. Yeah, same answer. Here you go. Okay, number 29. For those of you that are just arriving, I'm basically just going to do this until I get to the calculus and the statistics, and then once I get there, then I'm going to stop and do a different stream, maybe tomorrow, maybe the next day, with just calculus and statistics, because I feel like there's a pretty good divide when it comes to people that do UIL math. There's people that can get to the end of the test and the people that can't, and I mean, for a lot of the people that can't get to the end of the test, they don't want to see all that stuff. And for the people that are getting like 300 plus consistently, they don't need to see me do algebra 2, right? So hopefully that'll make it a little bit easier for you guys. But anyway, let's look at number 29. All right, Devin drops the ball from a height of 24 feet. On each bounce, the ball rebounds 3/4 of the distance it fell. How far does the ball rebound on the 10th bounce? So you can kind of imagine this as like a geometric thing, right? Each time it's being multiplied by this 3/4. So after one bounce, it'll rebound 24 times 3/4. After the second bounce, it'll rebound 24 times 3/4, and then times 3/4 again, right? Because it follows the distance that it rebounds, and then it has to multiply by 3/4 again. So after the third bounce, it'll be 24 times 3/4 to the third, and hopefully you can see where this is going. So after the 10th bounce, it'll just be 24 times 3/4 to the 10th power. And be careful because all your answers are in inches, so I'm going to have to multiply this by 12 in the end, because this is in feet. So 24 times 3/4 to the 10th, multiply that by 12, and you get 16 inches. There you go. All right, we've made it to number 30. Made it to number 30. Okay, find the perimeter of a regular decagon that can be inscribed in a circle with an area of 254 square centimeters. So the first thing I always do on here, if it tells me the area of a circle, there's not a whole lot you can do with the area of a circle besides find the radius. And also, I've done this kind of question before. So first thing you want to do is find the radius. So just divide that area by pi, take the square root, and you get 9 centimeters for your radius. So find the perimeter of a regular decagon. So I'm actually not going to draw the whole decagon. Whoa, that's a bad circle. That's a little bit better. I'm going to take advantage of the symmetry of the problem. So I'm just going to draw this triangle, and you can imagine that a decagon would be composed of like 10 of these triangles wrapping all the way around the circle. So my radius is 9. That's that right there. I can find this central angle because if there's 10 equal triangles all the way around, then 360 divided by 10 would give you 36 degrees. So that's 36 degrees right there. And I'm trying to find what this length is right here. So I'm actually going to cut this down the middle and say, well, now that's 18 degrees. That's 9. And so I'm trying to find this length right here. And then once I find it, I can double it to find the side length. So I have, let's see, sine 18 degrees equals my opposite over hypotenuse, right? So that's my side length divided by 2 divided by the hypotenuse, which is 9. And so, make sure your calculator is in degrees. Sine of 18 times 9 multiplied by 2. And so you get a side length of 5.56. But it doesn't actually want the side length, be careful. It actually wants the perimeter. Well, that's pretty easy. A decagon has 10 sides. So just take that, multiply by 10, you get 55.6 centimeters. Nice. For those of you joining us, I know we only have like 4 people right now, but that's okay. That's 4 people that are going to do better than everyone else. The link to this test that I'm working on, this is the 2022-23 test. So it's in the description of the video. You can go to that. If you have any non-calculus questions, because the calculus and statistics are going to be in a different stream. If you have any non-calculus and statistics questions, post them in the chat here, and I'm gonna work all of them anyway, except for the ones that are just very, very easy. But yeah, I can skip ahead to it if you guys want. So, in the meantime, though, let's look at number 31. All right, consider f of x equals x cubed plus bx squared plus cx plus d equals 0. 2 of the zeros are 5 and 2i. Find b plus c plus d. Okay, so we can actually find this equation. A cubic is going to have 3 roots, and they only give us 2, but that's actually not a problem because we know that for a polynomial, if you have one of the complex roots, then there's another root that's the conjugate. That's the complex conjugate. So our 3 roots are going to be 5, 2i, and by complex conjugate, I mean all you're doing is negating the imaginary part. So our third root is going to be negative 2i. All right. So from here, what we can do is say we can make a polynomial by turning it into factors. So to do that, our polynomial is just going to be f of x equals x minus 5 times x minus 2i times x minus a negative 2i, so x plus 2i. Right, so if we expand this whole thing out, which, by the way, you can do on your calculator. I'll show you this. If you don't want to FOIL this whole thing, which I don't blame you. You can go to expand, which is under menu, algebra, and then number 3 is expand. X minus 5 times x minus 2i, and you can't just type I, you have to go down here and get that. Times x plus 2i. You get x cubed minus 5x plus 4x minus 20. And what does it actually want? It wants to find absolute value b plus c plus d. So negative 5 plus 4 is negative 1, and then minus 20 is negative 21. So the absolute value of that is just 21. Right. All right, I actually don't know when the calculus and statistics starts, so I might, I didn't actually look at this test beforehand, which might have not been a good thing. But, we'll get there anyway. We'll get there anyway. All right, let's look at 32. Oh yeah, you're right. You can just plug in 1. It is a little weird. I was going to mention that. It's a little weird because of the imaginary numbers. Yeah, but if you have x minus 5, wait, let me read this. For this one, it's okay, but you can always plug in 1 for x and subtract off 1 for the leading term. It only works half the time. What do you mean only work? Wait, does this not work? All right, so 1 minus 5 would be negative 4, and then it would be 1 minus 2i and 1 plus 2i. Yeah, and then subtract 1. gives you negative 21, so you get so the absolute value of that is negative 21. I'm not really sure what you mean. It only works half the time. Maybe we're talking about different things. All right, let's look at 32 though. Oh, when it wants a plus b plus c plus d. Oh yeah, it's you have to adapt it a little bit, but like if you plug one in, you'll get a plus b plus c plus d, and then you know that a is 1 because it tells you, and then just find the absolute value. So yeah, I mean you have to work around it a little bit, but yeah, that still works. Okay, let's see. The vertices of the hyperbola 16y squared minus 9x squared minus 96y minus 72x minus 144 equals 0 are a comma b and a comma c. Find b plus c. Okay, I'm not gonna lie, finding vertices of hyperbola is very annoying. Um, I'll go through like the long way, and then I'll show you how to do it with like the conics solver. Unless you guys just want me to skip to the conics solver on the graph. But I'll isolate it like this. So I'll get all my y's together. 16y squared. Oh, my pen is acting up. Minus 96y, and then minus 9x squared minus 72x equals 144. Oh my gosh, my pen is struggling a little bit. Okay, here we go. Okay, then if I factor out the 16 from here, and factor out the negative 9 from here, right? Then now what I can do is complete the square. So for this on the inside, and I want to complete the square. The standard form of a hyperbola looks something like this. By the way, this is where I'm coming from. So basically, I'm just trying to get these squares. That's why I'm going through this. So y squared minus 6y, I have to add 9 in there, and then x squared plus 8x, so I have to add 16 in there. So, but I can't just do that. I have to add the resulting part to the right hand side. So 16 times 9 is, so I'm adding a 144 over here, and then minus 9 times 16. Okay, so I'm just subtracting 144. There you go. So those go away. And then I want 1 on the right hand side to get my standard form. So I'll divide everything by 144. So this whole thing divided by 144 gives y minus 3 squared over 9. And then this over here gives x plus 4 squared all over 16. And this equals 1. So the center, this hk is the center of my hyperbola. So because it's y, since it's a y squared and a minus x squared, it's going to look something like this. My center is at negative 4, 3. And then my vertices are here, right? And the distance from here to here is just down here. So it's y minus k squared over a squared, right? This a basically tells you the distance from the center to the vertex. So my a squared is 9, and so the distance between these two is 3. And so one of these points will be at negative 4, 6. One of these points will be at negative 4, 0. And so my b plus c, right, if I'm looking for b plus c, 6 plus 0 gives you 6. Okay, you can also do this on your graph. You go to add graphs, and then, what is it, relation. It's going to take some doing to remember this. 16y squared minus 9x squared plus 96y. Is it plus 96 or minus 96? Okay, minus 96y minus 72x minus 144 equals 0. Okay, so we get this hyperbola. The graph isn't super centered, but that's okay. It's not like way out there. So you go to analyze graph, analyze conics, and then number 2 is vertices. So if I look here, look, it shows us it's at 0 and 6. Right? Same thing. Saves a little bit of time. Up to you which one you want to do. Yeah, let's keep going. Okay, for those of you that have done calculus, this next question kind of looks like calculus, but it's actually not. Because there's not actually a limit. Usually when we see h's, we think it's a limit, but this one actually isn't. Let's see. Well, all you're really doing here is just plugging x plus h in and... Okay, actually, we don't have to do this one. This is really just like plugging x plus h into the equation, plugging x into the equation, right? Yeah, we don't need to go for this one. I'm going to skip this one. Okay, let's see. Consider a parabola with a vertex at 3/2, 1/4. If the vertex -2, 4 lies on the graph of the parabola, which of the following points also lies on the graph of the parabola? Okay, so we have 2 points. We know 3/2, 1/4 is on there. We know -2, 4 is on there. And because that's the vertex, the parabola is symmetrical around the vertex. And so you have this point, which is 3.5 to the left of that point, right? 3/2, or you can also think of this as 1.5. 1.5 to -2, that's 3.5 to the left. And so we're going to have another point that's 3.5 to the right that has the same y value, right? We can take advantage of the symmetry there. And so basically we have these 3 points. We have these 3 points, and we just have to find the parabola and see which one of these points also is on the parabola. Wait, actually, we kind of got lucky. So they kind of just took advantage of the symmetry already. So you can see this is our option, 5,4. Right, that's the whole problem. Oh, I thought we were going to have to solve the equation of the parabola and everything. But nope, that's just 5,4. Okay. How much longer until we get to the calculus ones? I'm just curious. Okay, it looks like 41 is the first calculus problem. Okay. Wow, and they don't let up, do they? Okay, 31 is the first calculus problem. So we've got a few more of these. Okay, find the angle between the line 3x minus y equals 6 and the line 4x plus 5y equals 9. Okay, so this is the formula that you're going to use. So the cosine of the angle between, and there's some linear algebra things that are going on here, but that's a little bit beyond the scope of what I feel comfortable teaching right now. I could go through it, but it probably wouldn't make a whole lot of sense. So it has to do with dot product, for those of you that are familiar with that. So the cosine of the angle between the lines. Basically, I'm going to write each of these as ordered pairs, where the x-coordinate is just the x coefficient, the y-coordinate is just the y coefficient. So we have 3, -1, and 4, 5. Right? So what we're going to do, we're going to take what's called the dot product. So multiply your two x's, multiply your two y's. So that will be 3 times 4 plus -1 times 5. And then you're going to divide by the magnitude of each of these. So imagine that you had a coordinate plane. And so 3, -1 would be right here. 4, 5 would be right there. The magnitude is just the distance from the origin to that point. So for 3, -1, you can use some distance formula or Pythagorean theorem, however you want to think about it. So 9 plus 1 gives you 10. And then 16 plus 25 gives you 41. And so now we can solve for the angle between these. So you should get 0.346 Take the inverse cosine, you get 69.8 degrees. Yep, that's answer choice A. Alright, we're almost there. We're almost to the end of the non-calc and non-stats. Okay, this one's actually pretty quick. But only if you know what to do, this one's really, really quick. So the graph of the polar equation r equals 3 minus 3 cosine theta equals what? So there's basically there's like an equation format, the same way you have like equation of a circle, equation of a equation of a hyperbola, all that stuff, equation of an ellipse. There's like a subset of equations in polar coordinates that look something like this. One of them is a plus or minus b sine of theta, and one of them is a plus or minus b cosine of theta. So you can see that this one kind of fits this second format because we have the cosine. So our a is going to be 3, our b is also 3, not negative 3 because see we have the plus or minus. And to find which one of these it is, well, it's not going to be a circle. Actually, I'm not sure how you would know that without further explanation. But okay, pretty much there's only a handful of options that you have here. This curve basically works for what are called limacons. You see that right here. But don't let that trick you because cardioid is actually a kind of limacon. So what you do, if a over b is less than 1, then this is going to be a limacon with an inner loop. And I'll show some demonstrations of this on the graph. If a over b equals 1, then this is going to be a cardioid. If a over b is between 1 and 2, then it's a dimpled limacon. And if a over b is greater than 2, then you'll have a convex limacon. So I'll kind of show you what some of these look like. So you have to go to your polar graph that's under 5. So this would be an example of a limacon with an inner loop. So maybe 2 plus 3 cosine of theta. So you can see we have the inner loop here. And this would be a limacon with an inner loop. Then if I make these equal to each other, so a over b would equal 1, you can see it makes like this heart shape, and this is called a cardioid. Now if I increase this to 4, see it's still kind of like that heart shape, but you see how now it's called the pole, how this right here, it doesn't touch, or how the dimple doesn't touch the origin. So it's still like a heart shape, but it doesn't touch the origin. This is called a dimpled limacon. So you can see, if I change this back to 3, right? It touches, that's a cardioid. It doesn't touch, a over b is between 1 and 2. Now it's a dimpled limacon. Now if I change this so that a over b is greater than 2, so 7/3 is like 2.3. Now you can see it almost looks more like a circle than a what am I trying to say? Than a dimpled limacon, than a limacon. And so this is called a convex limacon. So looking at what we have here, we have 3 and 3, so those are the same. And so we're going to have a cardioid. Okay, moving on, we're almost to the end. Okay, 37. Oh, we got some parametrics. Sweet. All right, the graph of the parametric equation, x equals 13 cosine theta and y equals 5 sine of theta, is an ellipse with foci of AB and CB. Find absolute value of A minus C. Okay, so you can see absolute value of A minus C, if you think about it, is kind of just the distance between those two numbers. So it's just the distance between A and C. That might come in handy later. We'll see. So the idea here is you have to use a Pythagorean identity. This is like a trig identity. And it's that sine squared of theta plus cosine squared of theta equals 1. And this comes straight from the unit circle. There's probably like 200 videos online or more of like proving this identity. It's not too complicated, but for now, this is what you have to know. So, so using this, right, sine of theta is, if I'm using this, would be y over 5. So sine squared would be y squared over 25. And then by the same logic, cosine squared would be x squared over 169. And that equals 1. So, the general form, here, let me make this look like more like an x. The general form of our hyperbola, of an ellipse is x squared over a squared plus y squared over b squared equals 1. And these a's and b's can move around depending on the situation, but a is always going to be greater than b. So sometimes the axis in the y direction will be longer, and if that's the case, then these will be flipped, actually. So these would be flipped if the axis in the y direction was longer than the axis in the a direction. Actually, let me draw this so this is a little bit more clear. So here's your ellipse, right? And you can see this is more of an x-oriented ellipse. So if here's your center, and these are your two axes. So this isn't a very good ellipse, but you kind of get the idea. So because this one's longer, because this is longer in the x direction, this would have a under your x, and this length right here is actually equal to a. And this length here, the shorter one, is b. So in this case, our a is going to be 13, and our b is going to be 5, right? Square root, because underneath here is a squared and b squared, not a and b. So, since it's x squared and y squared, this is just going to be centered at 0, 0, which you'll find doesn't actually matter. Wait, scratch that. That was a true statement, just ignore it because it was a little bit confusing. So, we have a is 13 and we have b is 5. We can actually find the length of we can find our focal length, which is basically just the distance, well, not basically, it is just the distance from the center to the focus. So like this length right here is c. And it kind of looks like the Pythagorean theorem, but it's a little bit different. So c is going to be the square root of a squared minus b squared. So for this problem, a squared minus b squared would be 169 minus 25, which I think is Pythagorean triple, actually. Yeah, so this just gives you 12. So our focal length is 12. So the distance from the center to the focal length, or to the focus, is 12. But what this is saying is we have two foci at AB and CB, right? Which is actually true. Like all ellipses have two foci. In fact, that's how the ellipse is defined. So that length is also C. And so this one's defined basically the distance between A and C. Well, if the distance from the center to this foci is 12, the distance from this foci to the center is 12, then the distance between A and C is just the sum of those two, which is 24. All right, moving on. Okay, let's look at this one. Consider the sphere x squared plus y squared plus z squared plus 4x minus 6y plus 2z minus 11 equals 0. Find the volume of the sphere. Okay, the standard form of a sphere, if you haven't seen this before, is x minus h squared plus y minus k squared. It's very similar to a circle. Plus z minus I think they use p squared equals r squared. And p is just the z coordinate of the center of the sphere. The same as like h and k are the x and y coordinate. I'm just using that for the z coordinate. So we have to get this into like a completed square equation. So if I write it like this, x squared plus 4x plus y squared minus 6y plus z squared plus 2z equals 11, right? I just moved the 11 over. Then when I'm completing the square with each of these, divide by 2 and square the x coefficient, right? Hopefully you're familiar with that. 4 divided by 2 is 2, squared is 4. 6 divided by 2 is 3, squared is 9. 2 divided by 2 squared is 1. But remember, I have to add all these to this side. And so, I've completed the square over here, and I'm good. Over here, all of this together is equal to r squared. Right, so 11 plus 4 is 15. 9 plus 1 is 10, so 15 plus 10 is 25. So that's r squared. So I have r equals 5. Right? But then I have to say, well, how do I find the volume of a sphere? Well, volume of a sphere is 4/3 pi r cubed. Right? And so if I plug in 5 in for r, squared cubed, and then I get a volume of 523.6. All right, moving on to 39. Oh, here's some linear algebra. Oh, I'm trying to remember how to do this. Oh, yes. Okay. So the unit vector orthogonal to both u equals 2i minus 3j plus 4k and v equals negative 2i plus 5j minus 7k is this vector. Some I plus some j plus some k, right? And I, j, k are just like the x, y, and z directions, for those of you that aren't familiar with that. And we're looking to find a plus b plus c. So the way you can do this, you're going to have to do 3 separate calculations. I'm not sure if there's a way to find a plus b plus c like in one swoop, but I do know how to find them individually. So one of my vectors is 2i minus 3j plus 4k. My other vector is negative 2i plus 5j minus 7k. So to find a, basically what I do is I ignore, since a is associated with the I, which is, since a is associated with the I kind of just ignore it, ignore all the ones that have i's, and then I make a matrix with what I have left over. So you can see I've kind of just taken out my i's. Now I have negative 3, 4, and 5, negative 7, like that. And then what I do is I take the determinant of this matrix, and that's A. And then it's similar for B, except now I'm taking the negative of the determinant. And there is an explanation for this process. It's beyond the scope of this video, but maybe I'll make a video in the future explaining why this is the case. So to find B, now I am ignoring the J's. So I have 2, man, this is not writing. I have 2, 4, negative 2, negative 7. Find that determinant. And then C, right? Absolute value, nope, that's not negative. We're back to positive. And that's not absolute value, that's a determinant. I'm struggling a little bit right now. So now I ignore the K's. So I'll have 2, negative 3, negative 2, and 5. So what's A going to be? Negative 3 times negative 7 minus 4. So A is going to be 1. Looks like B is going to be 28. And C is going to be 4. Okay, I've done something wrong, but that's okay, because we're going to figure out what it is. Okay, that one's right. Oh, that's because this one is 6, or negative 6. Or is it just 6? Yeah, it's just 6. Right, because when I find the determinant, I got negative 6, took the negative, and get positive 6. Right, so then when I add all these together, 1 plus 6 is 7, plus 4 gives you 11. Yeah, just memorize this for now. If you want to go look into why this is the case, I'm sure you can find something online. I might even make a video about this. But yeah, this is what you need just for right now. Okay, and I think this is the last question that does not require calculus or statistics. Let's go. Last one. I do need to copy and paste both of these though, because I need the graph. Okay, the points of intersection of the curves shown on the right are P and Q. PQ equals what? Okay, so normally you would just you would have to solve for the equation of this parabola and the equation of the line, but in this case you're looking at it and these actually intersect at lattice points. So this one's actually pretty easy. Like one of our points is at -2, -2, and our other point up here is at 4, 2. And so, right, distance formula, our change in x is 6 squared is 36. Change in y is 4 squared is 16. This is just the square root of 36 plus 16. Gives you 7.2, right? And that's it. That was actually a pretty straightforward question. It would be a little bit more annoying if they didn't give you the intersection points, because you'd have to solve for the equations of the things. In fact, you might have to do that for the next problem, now that I say that. Yeah, find the area, but yeah, you would need the two equations. But for this one, you don't. So that's it. That's all the non-calculus and statistics on this test. Oh, they give you 20 problems that are just calc and stats. That's a lot. Okay, for those of you that are still here, I hope you'll stick around for the calculus and stats stream. It's not going to be today. It might be tomorrow. It might be the next day. I'll post it on the Discord. But yeah, hope you guys learned something, and